If we can differentiate a curve, and when we do, it's not equal to 0, we say that that curve is regular. One way to think of this is if we look at our curve, we could draw that on a piece of paper without taking our pen off. Another way of looking at it is if a particle was to move around that curve, it would never slow to a stop, which means its speed is never equal to 0 as there's no gaps in the curve. So if we think about the speed, we know that speed, time and distance are very closely related. Our curve is in terms of t, which is time, and we can think of our curve as a vector, which is a bit like distance, so we can derive the speed from those two things, as we know, and from that we get that the speed is this function here, which isn't equal to 0 at any point, meaning that the curve is regular. But at the same time, it's obviously not equal to 1, it's equal to this function, so we say that it's not unit speed, as in it doesn't have a speed of 1. Now, if we want to make it unit speed, we could try and find another parameterization, and the way that we can do that is to reparameterize the curve that we've already got. And there's 3 steps associated with this reparameterization. The first step is to integrate the speed, the second is to inverse that result, and the third is to substitute that inversed result back into our plane curve equation. Now the problem with the first step is that we can't actually integrate our function by hand, but we can do it on a computer or in a calculator, and by using some simple codes in Excel we can do this numerically. So I'm just going to quickly go through what we did. So the first step, integrate the speed. Our computer told us that the function on the right in terms of t is our integrated function. And as an example, we're going to put just one value in, which is t equal to 1, time is equal to 1, and we get 2.238 out. Second step is then to inverse that. The way we do that is put 1 divided by 2.2384, and we get 0.4467 out. Now the final step, as we said before, was to substitute that value back into our original plane curve equation as so. And then we can plot all of those points, which is the reparameterization, and we can compare it to our original graph. And as we can see, it's the same shape, so we have managed to reparameterize it, apart from this time it does have unit speed.